mode. Thank you very much. My name is Denny Lee. I'm a developer advocate here at Databricks, but I'm just a low little host for today's session because we really wanted to feature the engineers at Scribd who are going to be talking about growing the Delta Lake ecosystem. So just in case you forgot what session we're doing. So without further ado, let's go ahead and introduce some folks. I'm going to go in whatever order my system shows it as. So we'll start with you, QP. Why don't you introduce yourself, buddy?
Yep. Hi, everyone. I'm QP. I work for the core platform team at Scribd, where I mostly work at data and ML infrastructure.
Perfect. That's great. Alexander, why don't you introduce yourself?
Hi, guys. I'm Alex. I'm a data architect at Scribd, and I also am a tech lead on the data engineering team.
Excellent. So you might not be able to see him, but he does actually exist. So it's not on his head. Tyler, why don't you introduce yourself?
It's good that y'all can't see me right now. So the director of platform engineering here at Scribd, and so I lead and sort of oversee the core platform team, which we have some members here from that team here today. The data engineering team and the data operations team all sit under platform engineering. So I'm usually the one that's, running the meetings.
Cool. At least you know what you do, buddy. All right.
Yeah, so, I know my place.
You know your place. All right, fair enough. And I was about to introduce Christian Williams, but I think we just lost him. So, all right. Well, whenever he comes back, we'll go ahead and introduce him. That was interesting. All right. So in that case, well, hey, Alexander, we're going to switch over to Karen. Let's switch over to speaker mode. Alexander, why don't you present the slides? And then that way we can go ahead and at least start the session. For everybody that's listening as we're setting this all up, the idea is that we're going to present only about a few slides, and then we want you to chime in with your questions. Please put your questions in the Zoom Q&A panel if you're actually coming here. The other place to put them, we will aggregate them from LinkedIn and also from YouTube. So just be a little bit patient with us. We might not be able to answer them right away, just because there is a lag between YouTube and LinkedIn with our current broadcast, but we'll do our best to try to respond. All right. So without further ado, let's switch over to the presentation. QP and Alexander, take it away, please.
Awesome. So I'm very happy here to talk about one of the open source projects that we're working on at Scribd with the community. It's called the Delta RS. Next slide, please. So Delta RS is a native implementation of Delta Lake in pure Rust, which means that when you're using this library, you can access Delta Lake read-write without depending on the JVM ecosystem. So it currently supports local file system, S3 remote storage, and Azure Data Lake storage Gen 2. Read is already well supported in the sense that we have tested with a lot of production tables and the golden test data set, and read is going really well so far. And thanks to Christian, we have a really early and native support for writing to Delta table. And we work, Misha from Scribd is also working on adding safe S3 multi-writer support to the library. And the write interface that we have right now, it's still pretty primitive in the sense that it interacts directly with the Delta transaction log. So we're also in the process of designing a higher level API where users of Delta Lake, Delta RS can write to the table with data arrow data record batch directly, so they don't have to interact with the transaction log at a low level. So in the next slide, I'm going to show you what it looks like from a high level architecture design of the library. So the pink and dark pink or red boxes here are all written in pure Rust. So at the very bottom, we can see that there's a Tokyo library, which for those who are not familiar with it, it's the async IO framework that's used within the Rust community. That's what's powering the async IO to the remote storage backends like S3 and Azure Blob Storage. And on top of that, we have Parquet and Arrow Crate. These are two pure Rust implementation of Arrow. that we heavily depend on. And then we have S3 client and Azure client. So on top of that, we have the actual implementation of Delta Lake logic that does the read and write to the Delta tables. And this layer has the stable end user API that for Rust applications. And then on top of that, we also leverage libraries like PyO3 to export those Rust APIs into other language like Python, Ruby, Golang, and Node.js. So one of the nice thing about this setup is it's really easy to extend this to any language or runtime you want by just throwing up a really thin layer on top of the existing Rust API, because Rust API it's really easy to export Rust APIs into a C compatible APIs that so basically will work for any language of your choice. So the Python implementation right now, basically we use all the core logic in the Rust implementation, which is really nice for us. And the Python binding, it's now ready to rock. If you just you can just use pip install to get started working on it. And there are some documentations in the repo as well about how to use the Python and Rust APIs. And one thing that I would like to mention is because the Rust API, we are using a bleeding edge unreleased version of Arrow Crate. That means if you want to use it in the Rust project, you have to install it using Git reference instead of a actual release in crates.io. But we're going to release a stable release once the new Arrow release comes out. So next slide, please. And of course, we're talking about open source community here. And the good news is Delta RS has a really active community. We have active discussions going on in the public Delta RS channel, which lives within the Delta Slack workspace. And over the last couple of months, we have gotten a lot of non-trivial contributions from the community. For example, Ben contributed async.io and Azure Storage backend support to Delta RS. And Florian contributed a lot of Python binding support to the library as well. And if you are into learning about Delta Lake or Rust, I think this is a really great project for you to get started. It's not too complex right now, and we have a lot of good first issues for anyone who want to get started on the journey. And we have a lot of people here to help mentor new contributors if needed. So with that, I would like to hand it over to Christian.
Actually,
hold on there, buddy.
Yeah, exactly. I was gonna say.
Oh, he's not here.
You're not done.
Yeah,
Okay.
you're not done.
You're not done.
You're not done. Yeah.
All right.
Yeah, we got questions for you, man.
Awesome.
I was kind of hoping that you might be able to explain. You might know this better than I do or our audience does. But what Apache Arrow does in the I don't think the Spark Delta implementation uses Apache Arrow. What does it do for the Rust implementation?
So currently, it's mostly at the library. So for Delta table itself, we mostly write to Parquet files to store the actual data. So the Parquet crates that we're using, it's built on top of the Arrow crate, which it also lives within the Arrow project. And so for the Delta RS implementation itself, we actually don't heavily use Arrow, but it's sort of like a transient dependency for us. But that's in the current state. Once we start working on the more advanced, higher level write API, that's where we actually start using Arrow, so that people can actually write Arrow record batch directly into a Delta table.
Excellent. So that's a great kickstart question. So now I'm actually going to go a little bit, scroll back up, and you may want to switch back to the slides to answer this question. But I guess the first things first is, why did you want to build Delta RS? After all, it's awesome, this idea that you want to, build the ability to not use Spark. So could you provide context on why you chose to do that?
Yep. So I think the next presentation or the next project that we're going to demo will be a good example of how this library can be used. So I'll leave that to Christian on that. And then the second reason that I think this could be useful is for local development, where you just have to spin up a Python environment and you want to load some data from Delta table into native pandas data frame, and this will work really well. You don't have to spin up a whole Spark cluster locally to explore it with Delta Lake. And the project that Christian is going to talk about will be a really simple subset of what you would typically do with Delta Lake. And I think once we get to that, we'll understand why that would be a good fit as well for this project.
There's also, when we look at what Scribd has in our technology stack, there's actually a fair bit that is not JVM based. Our data platform, because of the where Spark lives and the importance of Spark to most data infrastructures like our own, that's all heavily Spark oriented. But when we look to who's actually producing the data, that's flowing into our data lakes, it's largely things that are not running on the JVM. And so from a hand wavy strategic standpoint, the hope is that if we can extend writer and maybe some light read support to Ruby applications or Rust applications or Golang applications, that we can start to bring more of that data more quickly and from a broader set of sources into Delta Lake that we can then do the really fun Spark things with.
And another thing that I would like to mention is it's also always good to have alternative implementation of Delta spec, because we as a company is heavily invested in Delta Lake, and during the work of this project, we actually help contributed some corrections or into the Delta spec itself. So we found that there's some ambiguous spec wording in the spec that needs to be corrected. So I think overall it will be a really good thing for the Delta Lake ecosystem itself as well, with more alternative implementations.
No, that's an excellent call out. And yes, for those who are interested, all the stuff has been on GitHub, actually. So you can definitely see the conversations that happened right in GitHub about, oh, we've completely missed this part of the spec. We should call that out. So yeah, QP and Tyler and everybody else in this group had done those call outs in GitHub. So definitely join us from there. So this actually naturally leads to the next question. And Tyler, I'm going to ask it this time, but you can ask the other one. Can I use this in production yet, Delta RS? Of course, I'm hand wavy now at this point.
Should I answer it? Or
yes, you should. You should.
It's not production ready yet because we're still working on the S3 multi-writer support. But once that's done, it will be ready for production. And for read applications, though, I would say it's production ready.
Rock on. Yes. I mean, in fact, I know that you guys are using it, and then we've actually, myself, I've been working with some other customers who actually have been starting to use it themselves as well. So definitely loving the reading part. The writing part, there's some very active conversations. So if we flip back to the slide, we don't have to do it now, but whenever we do flip back to the slide, you'll notice our Slack channel, Delta RS. Yeah, come ahead and definitely join us there. Tyler, you want to ask the last question or should I?
I think I was just maybe QP, you could talk a little bit about how Delta RS actually maintains compatibility. I mean, having two different implementations writing into the same Delta infrastructure, I'm sure folks would want to know how we're going to keep in spec here.
So are you referring to interacting with the Spark implementation in production?
I'm just strictly referring to how do we make sure that how does Delta RS make sure that the data it's writing is Delta compatible?
Yep. So we actually share a same set of golden test data set with the main Delta connector project that we also touch on a little bit by Alex. So we share the same test data, golden test data set to make sure that every commit in Delta RS also pass those tests. And of course, we also try to follow the spec as strictly as we can.
Nope, that makes a ton of sense. Okay, perfect. Let's go ahead. The other quick question, actually, there is a quick question actually from the LinkedIn stream. Actually, I think I missed it, but I believe it was about when are we going to be supporting Google Cloud Storage? We did mention ADLS, we did mention S3, but poor Google Cloud. So I'm just curious, what's our plan for Google Cloud in that case? Oh, darn it. I think we just lost QP. Oh, well, this is what happens when we go live, I guess. And so, Tyler, I think you had
I
actually
might be able to answer that.
Yes, please. Could you answer that question since we lost more QP in the process? I guess I scared him with that question.
Hit the wrong
Dang
button,
it.
I bet.
My bad.
No, I don't want to support GCP. So there's actually an active issue in the project. There's issue 56. If anybody wants to go look it up. Basically, Scribd as a company, we're an AWS customer, so we're investing in the S3 support. And QP had called out Ben. Ben is interested as an Azure customer, is interested in Azure. We're kind of waiting for someone to step up to say, like, I really like Google Cloud. I can implement this support. The storage backends in Delta RS are fairly easy to swap out and implement a new one. So there's 3 storage backends right now. There's local file, S3, and then the Azure DSL, whatever that acronym is, that supports all there. So someone would just need to come in and add the Google Cloud Storage backend.
So in other words, I think what Tyler's trying to say is that, if you want it, come join us and help us out, right?
Well, one of the, I don't want this to come off as like a flippant, patches welcome sort of response. But one of the things that I've really enjoyed about the Rust ecosystem in particular is folks that are new to Rust. If you express an interest in, and this goes not just for Delta RS, but a lot of other Rust projects, if you express an interest and you want to try to figure something out, there's a lot of very helpful people in the Rust ecosystem that can help with some of the mentorship and pointers to sort of help you get started. So we've already seen this with a couple of individuals coming through the pull request process with Delta RS, where just going through code reviews with someone like QP, who's a very talented Rust developer, or Neville, who's another he's an Apache Arrow contributor. You'll learn a bunch of stuff. And it's been really interesting for me to actually watch some of the code reviews go on, because I'm learning things about Rust that I also didn't know. So yes, patches welcome, but we'll help you land those patches.
Yes, and in fact, not to go with Tyler's non-flippant response, if you're into it, like there's a bunch of us that can also very help you, not just on the Rust side, but also on the Google Cloud Storage side, that we could definitely help you there too. So absolutely would love help, just because, this is what growing the Delta Lake ecosystem is all about. Okay, nevertheless, QP will be joining us shortly. In fact, I think he's dialing in right now. Nevertheless, I believe we can flip back to slides, and the next on the docket is Kafka Delta Ingest. So, Karen, let's switch to speaker mode so that way we can show the slides nicely. And whoever's next on the docket, by all means, go for it.
That is me. But I was relying on QP for slides. So there we go. Perfect. All right. So I'm Christian Williams. I dropped off, unfortunately, due to bad connection in the introductory round. So just to introduce myself, I'm very much like QP. I'm a member of the core platform team at Scribd. I don't do any of the fancy ML stuff that QP does. I'm more of a data engineer and data platform infrastructure developer. And I happen to be working on Kafka Delta Ingest. So let's talk about Kafka Delta Ingest. The first thing to note here is Kafka Delta Ingest, if Delta RS is early on in development, Kafka Delta Ingest is very, very early on in its development. In fact, we only just merged our first major PR this past week. Our goal with this project is really to ingest Kafka data quickly and efficiently into Delta Lake, so that downstream Spark queries running on Databricks, either batch or streaming consumers, can read these data sets in near real time. As far as like contribution guidelines go, if you wanted to contribute to Kafka Delta ingest, Delta RS is by far and away the most critical dependency of Kafka Delta ingest. So any contributions that you might make there will help us tremendously. Especially issues, there's several posted that are related to topics like vacuuming, log checkpointing, and Delta optimization. The reason these particular topics are interesting for Kafka Delta ingest is that streaming jobs tend to leave small files behind, and that can really slow down ad hoc Databricks queries, because those queries are going to run most efficiently when there's large files at play, and specific queries that target large files. And we want our Databricks notebook queries to run fast. So building functionality into Delta RS that allows us to mitigate the small files problem by solving the problem there is going to be a huge boon to Kafka Delta ingest readers. Outside of Delta RS, if you really want to contribute to Kafka Delta ingest proper, there is an upcoming need for trigger once style jobs that would be a nice contribution that we'd love to see from the community in upcoming months. To be really honest though, we probably need to do a few more core cycles before this type of contribution would be feasible to submit from an external contributor. But if you find the concept of Kafka Delta ingest incredibly interesting, and you want to get in on the ground floor, there's no reason not to start kind of browsing the repository and getting involved in issues and discussions. If you're not familiar with the concept of trigger once streaming jobs, they're especially useful for low volume Kafka topics or streaming use cases that can tolerate a little extra latency, so they don't have to be like ad hoc near real time on the reader side. Basically though, rather than having streaming processes up and running 24 hours a day, 7 days a week, these trigger once style jobs will be launched in kind of a cron style on some interval. Read in everything from the upstream data source, which is Kafka for our use case in Kafka Delta ingest, up to the current offsets, and write that data to downstream before terminating, so that the next launch of the job can pick up from there.
Hey, Christian, actually, let me dive in with a little quick question. I want to roll us back up a little bit, if you don't mind.
Okay, sure.
Because I'm just curious, can you provide just at least for everybody that may not be familiar, why have you built Kafka Delta ingest? Like, what is the use case? What's the scenario you're trying to solve? Because I think for some folks, I think the natural question would be like, well, I could just put a Spark job and do it. And that's fair, right? But there's obviously very good reasons for having Kafka dump data directly into Delta using Kafka Delta ingest. So can we provide a little context on why that?
Sure, yeah, absolutely. Actually, Tyler has said has had a very short phrase that sums this up nicely that I can never remember the exact words of. So I'd love to let him answer this in that pithy phrase that he has.
We're going for pithy, right? Got it. Okay.
Uh-oh. I don't remember what you're referring to.
Uh-oh.
I mean,
I can give it a shot.
At a high level, Kafka Delta ingest for us, we want to make the fastest possible route from basically pulling bytes from one file descriptor out of Kafka and writing those to S3. We want as little overhead as possible, because we want things, when we talk about real-time query workloads that we're looking to support, we want those to be, certainly within a few minutes, but ideally within the minute, especially when we have some of these streams that are providing data to our customers that like just did a deploy, or they just flipped an A/B test one way or the other. We want to get that data to them as quickly as possible. So for us, Kafka Delta Ingest is solving the problem of, we don't want to run a tremendous amount of infrastructure just to take bytes from one descriptor and put them to another one. And that's where Kafka Delta, that's ultimately the root problem. Spark Streaming is actually a really, really great tool when you're doing something interesting with data on the stream. We actually don't need to do something interesting. We want to just shove it into Delta Lake as quickly as we can.
And just add to that, for real-time use cases like this, we also it also works really well to handle traffic spikes, where we can set up the system to auto scale as more traffic comes in, because inherently it's a master list design. There's no driver node, right? So every worker will just acting this the same role, and so it makes it really easy to auto scale based on traffic load.
That seems like a good segue to the slide that you wanted to talk to next, Christian.
Yeah, yeah, let's go ahead and put that slide up there. But just one last mention on just the overview. I just want to mention that early on, we're focusing in specifically on Kafka topics with JSON formatted messages. Further down the road, we'd love to add support for other upstream message formats like protobuf and Avro. And those would be great contributions to receive from the community if we don't get to them first. But yeah, we're focusing in on JSON because that's our use case, and it seems to be a very common use case out there in the world too. So, so going on to this deployment architecture slide. So just to show a tiny bit of the internals related to Kafka Delta Ingest. This is a picture of the deployment architecture we're targeting for Kafka Delta Ingest to run on. And in this slide, you can see producers write to Kafka topics. For example, we have topics A, B, and C here in the left column. A specific Kafka Delta Ingest job will read messages from one topic and buffer those messages for a while so that it can ultimately write a big chunk of data to a Delta Lake table. One Kafka Delta Ingest job, you can kind of zoom in on job P here and see that it may have many processes running within it. And we're leveraging Kafka consumer groups to assign topic partitions to specific processes within a job, and each process is then responsible for buffering and writing the data for the partitions that it's assigned by Kafka to write to Delta Lake files, all the while using Delta RS under the covers to do those writes. So that and table A, B, and C are kind of the outputs there for each Kafka Delta Ingest job. And that's pretty much all I wanted to talk about for Kafka Delta Ingest. It's a pretty simple concept that creates a lot of value and heavily leverages Delta RS for what it's doing. So I think I can probably leave this here.
Perfect. Well, I actually have got a lot of questions that we can definitely dive into, but I'll try to not overdo it because we only have about 20 minutes left. But for starters, let's go with even the more basic question. How does that JSON even become a row in Delta Lake for starters? Like what's the basic principle of how you even do that?
Well, I always have this tendency to go to like the fine-grained detail. Let me try hard to not do that. So on the producer side, what's that?
I was just saying it's all good, man. It's all good.
Yeah. So on the producer side, you might have a web application that's writing JSON messages to a Kafka topic, and a lot of people like to write those as in a JSON data format because it's really easy. You don't have to like bootstrap a bunch of protocol buffer, Avro schema type of stuff. You can just slap a string on a Kafka topic. So what Kafka Delta ingest is doing internally in our early iterations is reading those JSON messages off of the Kafka topic, buffering them up internally, and then using an API that's already provided by the Rust Arrow crate to decode those JSON values into an Arrow record batch. And so basically what Kafka Delta ingest is doing is it's just kind of buffering for a while, creating this buffer that sits in memory, and then once it hits a certain point, creating an Arrow record batch that is essentially the deserialization of those JSON messages into Parquet format, writing them to a Parquet data file, and then executing a Delta transaction. Hopefully that's close to the answer that we were looking for.
Well, no, I mean, it's just the answer to a question. So yes,
Sure.
But yes, I think that was actually very, very informative, in fact.
Okay.
Looking through any other questions, I guess I'm not sure we want to necessarily talk about it right this second, but there seems to be some implications about, since we're talking about there's the implication of some of the discussions we're already having on the Delta RS channel about about actually maintaining the transaction log. And do we want to talk a little bit about that here, or do we want to wait till we actually talk about SQL Delta import? Actually, I'm just curious.
So when you say maintaining the transaction log, that could go so many different ways. It might. I feel like maintaining the transaction log might be a good question to hold till after all three topics, and then we could maybe come back to it. Because I feel like it could very well cut across everything we're talking about.
No, that's fair. That's fair. Okay, let's talk about concurrency challenges in the transaction log as the tail end. In that case, why don't we switch to SQL Delta import, and then we'll come back to those two topics. How's that?
Okay, sounds good.
All
right, SQL Delta import time, ladies and gentlemen.
All right, hi guys. Once again, I'm Alex. Hopefully you didn't forget that by now, but I'll go ahead and talk to you about SQL Delta import. It's a utility that we developed here at Scribd to basically ingest our relational data directly into a Delta lake. And one thing I want to highlight here is Delta is directly, right? So some time ago, we took on an adventure of adopting Databricks platform here. And in order to get there, we had to migrate from our legacy Hadoop infrastructure. And somewhere around 20% of our nightly workloads, our batch workloads in that platform were Scoop jobs. And if you know, Scoop is basically a great tool that comes with Hadoop, and that can move data into HDFS, out of HDFS. Like it supports a lot of different use cases. And I want to highlight that SQL Delta import does not support all of them. SQL Delta import is used for one specific purpose, is bulk loading entire table from a JDBC source into a Delta Lake table. So why didn't we use Scoop? First of all, Scoop doesn't support Delta directly. We can import into Parquet and then do like additional conversion steps, but we wanted to not do that. In order to run Scoop, we also would need additional infrastructure, right? Like Databricks platform does not come with Scoop either. And also, as we were using Scoop in Scribd in prior years, we ran into some issues that we wanted to address as a part of this transition. So if you know anything about Scoop, the way you parallelize your workload is by introducing a parameter called number of mappers. So Scoop runs MapReduce under the hood, and when you specify, let's say, 10 mappers, it will use your split by column. It will go get its min max values, and then we'll use the parameter of number of mappers to basically split the source table into chunks that it wants to load. So when you do that, you run into some issues. For example, if you have like a very large table and your number of mappers is small, you'll have a very long running scoop job and like really long lasting connections that, as we know, tend to go down once in a while. If you go and bump up your number of mappers too high, you might actually overload your underlying data store with concurrency, right? It might not be able to handle all of those connections. And the last piece is, if you think about it, in scoop world, number of mappers directly corresponds to the number of output files that you're going to get on disk. So if you go with too many connections, you'll have too many mappers, you'll have small files. Not enough mappers, large files, I guess not as much of a problem. So what did we do differently in SQL Delta import? We basically decoupled this parallelism with the load on the source data store and the number of output files. We still do the same basic thing by using split by column to split our workloads by, but we also introduced this parameter called chunks to basically tell how many chunks you want to break up this table into before loading it. But then the parallelism is actually controlled by the regular Spark parameters like number of executors and executor cores. So this allows you to break up your import into, let's say, 2,000 chunks, but only use at most 100 executors, which will translate to at most 100 connections to the SQL, to the underlying SQL data store. So another problem we were able to solve by doing this is the data skew on a split by column. And I think I'll demonstrate that in the next slide. So we as developers, we have this tendency to always use auto increment primary key column on all of our tables. And then without thinking about it, we'll use that as our split by column when we import the data. So what happens when these tables go through iterations of their life cycle? We tend to add columns. We tend, when we add columns, we usually keep all the previous rows with null values. So over time, what happens, as you see on the top picture, is row density increases over time. So if you use your standard split by setup, right, your first partition will have actually less data, and your last partition will have the most of the data when you're importing it in. So this will introduce data skew, maybe not as drastic of a data skew, but nevertheless. Another problem that we ran into when dealing with importing data here at Scribd was non-uniform data density, because at some point in time, somebody will just go and delete a range of rows. So if you look at the bottom picture, like partition number 2 doesn't do any work almost, right? And the last partition is doing most of the work. So if you do this with scoop and you set number of members to 10, you'll, first of all, you'll get a processing time skew, and you will get highly varied output file sizes when this lands on disk. So how can you solve this using SQL Delta import? Well, you can cheat. You can just say, hey, give me 1,000 pieces, right? Give me 1,000 chunks. Keep the degree of parallelism low to, let's say, 10, whatever, 60, however low you want to keep it. But what will happen then is those empty chunks, the executors working on them, they'll just quickly process them and move on until they basically get to a chunk with where they can do some real work. And at the end of the day, since we're using Delta to write all of this too, we basically can optimize the output to make sure we get the optimal number of files. So let me maybe talk a little bit how we got it set up today at Scribd when we moved into the cloud. This actually fits pretty nice in to our cloud setup. So in the cloud, we have dedicated replica for our imports. And during the day when we're basically not running any imports, it's a very small sized scaled down Aurora cluster. When we start our import process, first of all, we pause the replication to make sure we get a consistent view in time. And we heavily scale out our Aurora clusters so they can deal with the massive amount of connections that Spark is about to throw at them. And whenever the imports are done, we resume the replication and we scale our Aurora clusters back down. And this actually works out pretty good for us. We can import our data really fast, and at the same time, we can also control the costs of our clusters. And this is like a nice view of our entire import process that brings in like almost 300 tables within an hour from our MySQL databases into Delta Lake. You can see that we start with only a couple nodes, and as the imports pick up, we auto scale and bring additional nodes in, and they pick up connections, and yeah, and get work done. If you want to learn more about this, please follow our blog. We just actually posted a blog post which goes into like a lot of details on how to use it, why use it, and all things of those nature. And we are, yes, go ahead, Denny.
I was about to say, Alex, we've actually already posted the blog in LinkedIn, YouTube, Zoom. So we got that. Let's go back one slide, if you don't mind. This is pretty sweet because you've called out the CPU utilizations. So then I'm just curious, in your environment, oh, actually, I'm sorry, one slide before, because it's actually about the Aurora sources. Does SQL Delta import in the process, because of you seeing all that CPU utilized, does it actually scale out Aurora in essence? Is that what's happening too in the process?
So we have Aurora set up to auto scale. And basically, we had to play with configuration on both sides. We are using connection-based auto-scaling in Aurora. So once a certain number of connections hook up to a cluster, it starts scaling up. And we also actually had to tune down the speed at which the Spark clusters auto-scale. So in Databricks, we have the parameter to tune how quickly Spark clusters go up to full capacity. So we slow it down just a tiny bit to give Aurora time to scale up and handle all of those connections.
Oh, that's pretty cool. And so is that part of the reason why I'm seeing that delay in CPU utilization like that? Or
yeah, these are basically, we don't like, we wanted to avoid manually scaling up and manually scaling down our clusters. We want to rely on auto scaling as much as possible. So this delay is actually additional nodes coming online.
Right. Okay. No, basically, it allows a little bit of delay, so that way they can actually kick in. So you're not also using warm pools or anything like that. Got it. Okay, fair enough. Then right now we've got a question actually here through Zoom. Is MySQL the only database that's supported for now?
And the answer is no. MySQL is what we use in production, but one of the parameters is, I guess we don't call it out. You can connect to any JDBC data source. So as long as, because under the hood, SQL Delta import uses Spark JDBC to do all of its magic, right? So JDBC connection is actually one of the parameters that we take. So anything that's JDBC.
Sweet. So you mean literally I can just go ahead and, even if I wanted to toss it to SQL Server, I could using a JDBC connection. I just would probably want to mess around with the parallelism configuration so that way I can throw more threads at it. Is that the context?
Pretty much, yeah. Yeah,
okay.
you like really you're messing with parallelism configuration to make sure you don't bring down the SQL infrastructure, right?
Yes, I've been very guilty of doing that. Go ahead, Tyler.
Denny bringing down databases?
No, never do that.
I know, like I remember watching the deployment of this as we brought this into production. Could you maybe talk about some of the replication coordination that we do, or any of the other like pitfalls that we ran into with basically bringing this to production with Aurora?
Replication pitfalls. You'll have to be a little bit more specific there, Tyler. There's two types of replications that basically happening here. One is a replication from our primaries into Aurora cluster. And for that, we are using standard SQL replication. And within Aurora cluster itself, there is magic Aurora under the hood replication. Magic
replication.
Well, you have to kind of, I don't want to get into the weeds of how Aurora internally replicates its data and how they use dedicated storage nodes. But basically, it's super fast. It's nothing like a standard MySQL replication. And it allows, this is why we can actually scale out so quickly. When the additional nodes come online, the storage nodes are already available for them. So that works out great for us.
There's a good question that came in through Zoom that I want to hear your answer to, Alex. So SQL Delta Import's doing this like bulk nightly import for us right now. What about change data capture? Is SQL Delta Import going to do that at any point?
There, the answer is we'll take pull requests, right? So, or we'll write it, right? So it really. The way it works is basically, here is my minimum value, like under the hood, it gets min value, max value, and then splits the load between those two, assuming some form of something close to uniform distribution. The min value doesn't have to be the absolute minimum. It could be the minimum value since last time you imported, right? There is nothing built in, but it's super easy to add. And yeah. I guess I'll stop there.
No, this is perfect. Okay, we've got about like 5 minutes left, and Karen, I think I'm supposed to still leave 2 minutes for you to close it up. So I did want to, at least as a group here, for us to talk a little about just a tiny bit about concurrency and the transaction log. So QP, Chris, Tyler, Alex, whoever wants to go first, let's dive right into it.
Yeah,
I nominate QP.
It's a
really QP. There you
it's
go.
It's a fun and complex problem. We can geek about this for hours if you want, but the quick overview on that is because S3 is not a strongly consistent data store, that means we cannot. It does not support CAS operations. So for those who don't know about it, it's compare as swap. So in order to do safe concurrent write into S3 from multiple writers, we have to also leverage DynamoDB. And there are, we actually have a really lengthy discussion about the concurrent write design in the open source GitHub repo discussion section. So I recommend anyone who's into distributed system database design to check that one out. But we have two leading design right now, and we're going with one of the DynamoDB log design, so that the benefit of that design is it's simpler, and it allows reader to open source reader to also read the table without any customization at the trading at the sacrifice of minor liveness problem, and that we'll be just dealing with in the design. But I recommend anyone to check that discussion out.
So QP, maybe you could also explain, why do we have to do this in Delta RS? I mean, does Delta have the same problem, or how do people in Spark deal with this?
So if you're using Databricks, if you are a Databricks customer, then you're fortunate that Databricks already handles this multi-S3 writer for you. And if you're using open source Spark writing to S3, you can only write from a single writer. And for Delta RS specifically, because we're using it in Delta Kafka Delta ingest project, where, like I said earlier, every process within the deployment has the same role, where they will just write to the Delta table concurrently, right? So there's no much coordination between any of those. So that's why we have a really high concurrent heavy workload in that use case. And that's why we have to make sure that when we write into Delta RS, we have to properly support concurrent S3 write.
Perfect. One of the things I did want to call out is like this is actually specific to S3 because Azure Data Lake Storage,
Yep.
ADLS, and also Google Cloud Storage actually does have that capability. So it's actually not required for those two sets of cloud object stores, but this is specific to S3.
Yeah, exactly.
Yeah. Okay. Hey, we could go on for hours, but this is only a 1 hour show. And so please do join us as per the links that we've posted into Zoom /YouTube/LinkedIn, because we'd love for you to dive in with us, because there's a lot of deep dive geeky stuff here, which is if you're into that, that's exactly where you should join us. But saying this, because it's almost time for us to wrap it up, Karen, why don't we go ahead and have you wrap up the show for today? Again, before you do, thank you everybody for attending, and of course, more importantly, thank the Scribd folks for coming and joining us for today's session.
Thanks, Denny. Yeah, I just want to echo that. Thanks everyone for joining us for this session, and great job everyone on the Scribd team. We're always happy to have you. And I just dropped the link to the video recording in the chat spaces. So join us there. I'll also drop all of the links that were referenced throughout the session in the video description. So with that, I'll just say thank you again, and I hope everyone has a great rest of your day. Take care.